Good afternoon to everyone. Thanks for subscribing my channel and thanks for viewers who are supporting me and who are encouraging me. Thank you so much. So keep this spirit and continue this spirit. Thank you so much. Because of your support, I'm able to recording and explaining the topics and recording the videos. Thank you so much. Thank you very so much. Then um, let us summarize. Let us summarize the graphical representation of motion. As previous videos, we discussed the graphical representation of motion. Graphical representation of motion. Here, let us take some brief recapitulation. So, in case of distance time graph, distance time graph, distance time graph, the slope is represent, the slope is represent speed or velocity, speed or velocity of the body, speed or velocity of the body. Then if the slope is, if the slope is straight line, the slope is straight line, then the body is said to be, the body is said to be in uniform motion. The body is said to be uniform motion. Then if the slope, if the slope is curved line, if the slope is curved line or a parabola, or a parabola, then the body, then the body is set, then the body is said to be in non-uniform motion, non-uniform motion. So these are the key points in distance and time graph, distance and time graph, right? So we can calculate the speed, we can calculate the speed from distance time graph. So to rough diagram I will draw here. Time, distance, time, distance, x-axis, y-axis, it is uniform motion. X, y, time, speed, it is non-uniform, non-uniform. This slope represents the speed of the body. Then coming to the second one, speed time graph, speed time graph, speed time graphs అయితే where we have two cases. The first one is, the first one is speed is at constant, speed is at constant, speed is at constant. Here the straight line which is parallel to time axis, parallel to time axis represents represents a body is in uniform speed or at constant speed. Constant speed. So, no acceleration. No acceleration. No acceleration. Then, so we can calculate distance traveled. Distance traveled. Here, how the distance the distance is equal to area of area of rectangle. Area of a rectangle. That means like this, x-axis, y-axis. So time, speed. Time, speed, the graph like this. So this is represent distance traveled. Distance traveled. This line represent constant speed. That means no acceleration. No acceleration. This is first one. Then in second case లో 3 ఉన్నాయి మళ్ళీ. Speed changes at uniform rate. 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 First one ఏంటి? Speed increases. Speed increases uniformly. Speed increases uniformly. Here the slope is acceleration. The slope is acceleration, that is positive acceleration. Then the distance is equal to area of triangle. Area of triangle. So rough draw the time, speed or velocity, x-axis, y-axis like this. So this represent acceleration. This represent acceleration. When we know the speed, this is represent distance traveled. Distance traveled. This is the first one. Then this B, second one, speed decreasing. Speed decreasing uniformly. Speed decreasing uniformly. Then what will happen? The slope, the downward slope, the downward straight line is represent acceleration. Is as usually the area of triangle is distance traveled. That means like this, x-axis, y-axis, time, velocity. So this is distance, this is the acceleration. Here negative acceleration. Negative acceleration. Right? So these are the second situation, in case 2. Then we have one more case. If speed not 0, if initial speed not 0, the third one, what will happen? The slope from any point represent acceleration. Any point represent acceleration, right? So acceleration is final velocity minus initial velocity by time. Then the distance traveled is equal to area of trapezium. Area of trapezium. Area of trapezium. That means when you draw the graph roughly, area of a trapezium. So this is the trapezium, right? So this represents distance traveled. This represent acceleration. X-axis, y-axis, time, velocity. So in second case, again we have 3. Speed increases uniformly, speed decreases uniformly. If initial speed not equal to 0. This is the positive acceleration, negative acceleration, nothing but retardation or deceleration. If then the third case, is then speed is constant, speed changes. So speed changes non-uniformly. Speed changes non-uniformly. Then we get a curved line. So this represent acceleration. This represent acceleration. So this is the overview of graphical representation. Graphical representation of motion. Here uniform acceleration. Uniform acceleration. Here non-uniform acceleration. Non-uniform acceleration. So this is about graphical representation of motion. So whenever you have to summarize the topic like this, then it is very easy to understand. So um, later we discuss Later we discuss problems based on the graphical representation of motion. So read your textbook, underline this kind of points, then draw the rough work, then it is very easy to understand. Thank you.